So I'm back with another example on using the implicit differentiation technique. So guys, again, here we can see that we have this equation, and this equation is like an implicit function because we can see it's a mixed combination of x's and y's all mixed up together. And then we want to find the derivative of y with respect to x, but we just don't want to just stop right there. We also want to write an equation of a tangent line given the points. Guys, the good thing here is we already have the x1 and both the x1 and y1 point, so we don't have to do that extra work to evaluate or calculate the y1. It is already provided to us. Guys, first of all, let us look at the equation one more time. We can see that x's and y's are all mixed up. Yes, it is still not such a complicated equation. We may still be able to solve for y explicitly, but guys, that is still going to be some extra steps, and then even finding the derivative of all that is also going to be more work. So we don't want to do none of that. All we want to do is we want to see that this is an implicit function, x's and y's are mixed up, and whenever we have something like this and we are trying to find the derivatives, we start by applying derivative on both sides. That is, guys, always going to be the case. Don't try to isolate any y's, or don't try to bring any of the terms together or whatever. Just start by applying derivative on both sides. So let us start doing it. Guys, we want to write all the steps clearly so that we don't make any mistakes. And keep in mind, we know, like back in our minds, we should know that y is a function of x. It's y of x, okay? So apply derivative on both sides, so it's like d over dx of x square y square minus 2x. And if I apply derivative on the left hand side, we have to apply derivative on the right hand side, because whatever we do to the left hand side, we got to do the same thing to the right hand side. So it is d over dx of 4 minus 4y. Now we got to break it down into different pieces. Guys, these are two pieces here, so it's going to look like d over dx of x square y square minus d over dx of 2x. That takes care of the left hand side. And on the right hand side, again, we got to do the same thing. We're kind of distributing the derivative. That's one of the basic properties of derivatives. If you're taking derivative of a function which is like more than one function, you apply it to each individual function. So it is like d over dx of positive 4 minus d over dx of 4y. So now let us try to simplify and actually evaluate the derivatives if it is possible for us to do that. Guys, here obviously we can see that it's a product of two functions, so you can think of this as f and this as g. And let us remind ourselves what is the product rule, guys. The product rule says if we are taking the derivative of f times g, it is going to be f prime times g plus g prime times f, and that's exactly what we're going to do for this function. Take the derivative of x squared, which is just 2x, and then I have to multiply by y squared, that's the g function, plus then next step is to find the derivative of the g. Guys, keep in mind for this we have to use the chain rule. So using the chain rule, first I bring the 2 in front. Well, basically first I'm using the power rule, and using the chain rule is basically means we got to multiply by the derivative of the inner. And guys, keep in mind, you can think of this as y in parentheses, it's y of x of whole square. Y is a function of x whole square. So you bring that 2 up front, and it's then y to the power n minus 1. 2 minus 1 is just 1, so I don't have to write that invisible 1. Then we have to multiply by the derivative of the inner. So here y is not an explicitly written out function, so we have to write it in a notation way, which is dy over dx. That would be the derivative. I mean, we don't know the value of that yet, but that's how we're going to write it. Guys, moving on. We cannot miss one more thing. Sorry, guys. We still have to multiply by the f function. So f function is x squared. So we want to still multiply by x squared. That completes the derivative of that first product, and then minus derivative of, guys, 2x. You can just take out that 2, then dx over dx is just 1. Derivative of x with respect to dx is 1. So it is just going to be negative 2. Guys, right hand side is not too complicated. Derivative of a constant is 0. So I can write that 0 here. Then minus, guys, with this, I just have to take out that 4, right? When I take out that 4, I'm only left with dy over dx, because we cannot really evaluate that derivative. All we can do is we can just write it with dy over dx form, okay? Guys, once we have applied the derivatives on both sides, we simplify. Now, again, let us remind ourselves, what are we trying to find? We're trying to find dy over dx. What does that mean? That means we should have dy over dx terms on one side and everything else on the other side. So what I'm going to do is, guys, I'm going to first figure out which are my dy over dx terms, or which terms have dy over dx in them. So this is one of the terms that has a dy over dx. And then this is another term that has dy over dx, right? Everything else does not have a dy over dx. So what I'm going to do is, I'm going to bring this term to this side, and then these two terms I'm going to take it to the other side, so that I can isolate dy over dx terms. So what is going to happen here is this 2y And guys, I'm going to bring that x squared up front. I'm just rearranging it. And then I have dy over dx. And then when I bring this to the left hand side, it is going to be positive 4 plus 4. And then I have dy over dx. Guys, you have to be patient with these examples because they require a lot of time and they require a lot of patience and because there's a lot of steps involved here. And then when I bring this and this to the other side, obviously this is going to become positive 2 and this is going to become minus 2xy squared. Okay, that is the right hand side. So from here, guys, again, keep in mind we want the dy over dx by itself, right? So we got to take out the dy over dx as a common factor. Although I can also take out 2 as a common factor, but guys, I'm not going to do that because all I want is dy over dx. So I'm going to take dy over dx, and then let us see what is left inside the parentheses. I have 2y x squared plus 4 that's left here, and then here, guys, we should not simplify, or what we can do here is maybe we can just take out the common factor, which is 2, and then what is left inside? 1 minus xy squared, right? So guys, once we have this, keep in mind our goal is to find dy over dx. To get dy over dx by itself, we need to get rid of this term. How can we get rid of this term? We just divide both sides by that. So I'm going to divide both sides by 2yx squared plus 4. If I divide left hand side, I got to obviously divide the right hand side. So 2yx squared plus 4. Guys, this crosses out. Once this crosses out, what do I get? I get dy over dx on the left hand side, and that is exactly what we wanted to find for part 1 of this problem, and that's going to be 2 times 1 minus xy squared, and this whole thing has to be divided by this guy. But guys, here you can clearly see that we can take out 2 as the greatest common factor, which I'm going to do here, and then what is left inside? I'm left with yx squared plus 2. And guys, this 2 and this 2 can cross out. I'm only left with 1 minus xy squared divided by yx squared plus 2. So that is my derivative of x with respect to, derivative of y with respect to x. And I want to make sure, check with my notes if that's exactly what I have. Yeah, that's exactly what I have in my notes as well. Guys, this is my dy over dx. We are done with this part, and now we have to write the equation of the tangent line. So to find the equation, first you have to find the slope. Slope is just the derivative, but at a particular point, and that point, the coordinates of the point are already provided, 2 and negative 2. So m tangent can be calculated using this equation for the derivative, but substituting x2 and y negative 2. So it's 1 minus 2 times negative 2 whole square. I'm just replacing x with 2 and y with negative 2, and then here I have y is negative 2 times I have x squared, which is positive 2 squared plus 2. We should carefully evaluate this, guys. If you are using a calculator, please make sure you put the negative terms in parentheses, or I mean, for something as simple as this, we don't really need to use a calculator. 1 minus, guys, negative 2 squared is 4, and 4 times 2 is 8, so it's 1 minus 8 divided by 2 squared is 4, 4 times 2 is 8, but it's going to be negative 8 plus 2. When I simplify this, 1 minus 8 is negative 7, negative 8 plus 2 is negative 6, negatives will cross out. So what do I have? I have m tangent slope is 7 over 6, right? I have my slope, I have my points x1 and y1. Nobody can stop me from actually writing my equation of the tangent line. So let's go ahead and write that equation of the tangent line, and we'll be done with this example. So writing the equation of a tangent line, we know, I prefer the point slope form, which is y minus y1 equals to m x minus x1. If you like the other one, the slope intercept form, that's totally fine. You can use that as well. But guys, since the point is already provided to me, it's convenient for me to write the point slope form. So it's going to look like y minus y1, which is negative 2 equals to m. Keep in mind this is m tangent, 7, 6, and then I have x minus 2, and if I try to simplify, maybe we should simplify this. Negative times negative is positive, 7, 6, and then x minus 2 in the parentheses. Guys, this is the equation of the tangent line, and we have the derivative right here. So we have to do all these steps to finally get the equation and the derivative. Guys, this is example 2. Guys, don't make it too complicated. Just use the idea of the chain rule. Of course, there's a lot of steps. One has to go through all the steps. One has to write all the steps clearly so that one does not make any mistakes here. So guys, I will see you next time with another example. Till then, guys, keep practicing. If you have any questions, please reach out to me through my YouTube channel. Till then, take care.